Welcome to Lecture 4 of Stanford CS193p, spring of 2025. And today, it's all about model and UI. And we're going to just dive into making our CodeBreaker have a separated model and UI. And because it'll have a model, it'll be able to play the game by the time we're done today. It'll be fully implemented gameplay. And that's all we're doing today. Let's head back over here to Xcode. This is where we left off last time. We're going to start right off the bat here by creating our model. Our UI right now is mostly a prototype, right? We've got hardwired little test codes in here and hardwired match markers. It's all prototypical. So we're going to make our model, and then we're going to come back to our view and turn our UI into what I said, a kind of a manifestation of our model. So what is our model going to be? Our model is just going to be a struct, actually a number of structs, and a lot of models are just structs. Our model, again, it could be a SQL database or some other stuff, and later in this quarter, believe it or not, our model is going to be a SQL database. That's how far we're going to take CodeBreaker from where it is now to where it's going to be, but we're going to start off, it's just going to be a struct. So how do I create a new struct? Well, the only time we saw creating a new file here, it was when I did the copy, right? I copied an entire helicopter view and then created a new file from it. But that's not normally how we create it. We usually go to File and New, and then do this one, File from Template. And you see the one right above it, Empty File? I recommend against that one. Because when you do File from Template, you're going to tell Xcode what kind of file it is, and it knows whether to add it to the list of things to build and its dependency charts and all that. So we almost always want to go File from Template. And when we go here, there's actually only two templates we're probably going to be picking in this class. One is SwiftUI View. That's going to give you a little template with struct something behaves like a view and var body. And then there's this one, Swift File. This is going to give you an empty Swift file. Now your model is most certainly not a view. It has nothing to do with the UI. So we will always choose Swift File when we're building things that are in our model. So I hit Swift File here. Now it's saying, what do you want to call this thing? And I'm going to start with the struct that is the heart of our model. I'm going to call this struct CodeBreaker, because it's going to be the thing that plays the game. It deserves the name CodeBreaker. One thing I'm going to say really quickly while I'm here is this little group. You see this group? See the choices here? Sometimes this will be on this setting right here, the topmost one. That means put it at the top level of your project in terms of the files over in the navigator there. Don't put files there. Now, if you accidentally don't notice this and you do it, you can just drag it down into the right folder. But really, we want all the files to be in this folder, the CodeBreaker folder, or subfolders of that. We can certainly divide our files up into subfolders for organizational purposes, like maybe we have a folder for our model files and a folder for our UI, whatever, that's fine. But just keep an eye on this one here. I create this file. I'll show you in the navigator. Here it is. It's called CodeBreaker. Right here was our content view. Here's our CodeBreaker. And CodeBreaker imports Foundation at the top, not SwiftUI, Foundation. Now, I am going to, unfortunately, change that import Foundation to not be import Foundation, and it's going to be a bad thing. And sometimes you learn by seeing your instructor do a bad thing, and you're going to see me do that soon. But no, not to worry. You're going to fix it in your homework. Assignment 2, you want to put this back to Foundation, because we do not want to import anything but Foundation here, or maybe Swift Data or other things that are Model-E, non-UI things. But I'm going to have to do it just for simplicity briefly here in this lecture, okay? So when you get your Assignment 2, you're going to see you're going to change this model, and it's going to go back to where it can be import Foundation. So let's just dive right in and just try and think, what would a CodeBreaker model look like? And when we're trying to answer that question, we're really asking the question, what is CodeBreaker? Because our model is what we're making. The UI is just a manifestation of that, but the model is it. So what is CodeBreaker? So we're going to make it be a struct. I'm going to call it CodeBreaker. It doesn't behave like a view or anything like that because it's not a UI thing. And we just got to start to ask ourselves, well, you know, what storage, what functionalities does this thing have? Well, CodeBreaker has codes. Okay, we got to break the codes. For example, it has a master code. Now, what type might my master code be? I really don't know, so I'm just going to say it's a code right now. And that's obviously nothing. Code does not exist anywhere, but that's kind of conceptually what I want. And there's other codes, like there's the guess. That's the code that I'm currently working on. There's the attempts that people have made to guess my code. That's an array of codes, right? Remember, this square bracket code is the same as array angle bracket code. What else is there besides codes? Well, when we're playing the game, we have a bunch of pegs of different colors. So the game kind of needs to know what are those colors. So we know like the choices we have for pegs, you know, red, green, blue, yellow. Do we have other colors? Like Mastermind actually did have other colors, like it had black and white pegs. I didn't put that in there because I didn't want you to get confused with the black and white pegs, which are the match markers. So I think I would need a var. I'm going to call it peg choices, which is an array of pegs, basically, right? Pegs that I can choose from to make my codes out of. And I actually thought about it, and I think this is all there is to a code breaker. This is all the storage is, those kind of codes, and then the choices for making it. Otherwise, what CodeBreaker is a bunch of functionality. Guessing and matching and doing those with black and white markers, all that stuff. That's what CodeBreaker is. But in terms of storage, this is pretty much it. Now, it's interesting. Look, the AI wants to add a function, make guess, to our CodeBreaker. This AI, pretty cool, right? I mean, it figured out CodeBreaker must be some kind. I have guess there. Anyway, kind of fun. Anyway, we're not going to do that, but it's interesting to see what it suggests sometimes. But I use some types up here, code and peg, which don't exist. So we got to create those. All right, struct code. So what's in a code? What is primarily a code? It's basically pegs, right? 4 pegs makes a code. So I need a var the pegs, and pegs is an array of pegs. And so that's obviously in a code. What else is in a code? Well, I gave this some thought, and I thought, well, there is one thing about a code, which is its type. Is this a master code? Because then I got to hide the pegs. Is it a guess, in which case it's like an editable code, because I'm guessing? Is it an attempt, in which case it's a non-editable code, but I can see them, the previous attempts that I've made. So there's a difference there. So I'm actually going to make an enum in here called kind, which is my kind of code this is. And I made it an enum because there's 3 very discrete kinds of codes: master codes, guessing codes, and attempts, previous attempts. So I'm just going to say case master code, and case the guess, and case an attempt. And sometimes we know we might put something like, what if I had an unknown code or some other kind of discrete case here? Although a lot of times, if we mean unknown, we'd use an optional, right? And I would make this kind, which is going to have to be a var here, the kind of thing, I would make it an optional kind. And if it was nil, then it would be like an unknown kind. But I'm not going to do that to you because I know optional is new to you, and I don't want to be putting this optional, you know, syntactic sugar, the question marks and all that stuff in front of you so much. So we're going to make kind not do that. We don't need unknown. All of our things are known, but I'm going to leave this in here because actually in 4 weeks from now, we will briefly need unknown, and you'll see why. But I'll just put it in here. You'll forget about it, and that's fine. And then what else we got? Peg. I see red things here. Oh, yeah, question.
Why do we put the enum kind within the struct?
That is a great question. The question is, why did I put enum kind here inside this struct? I've never done that before. So why did I do that? Well, I actually did that intentionally. And what does it mean to put a type inside another type? It's namespacing. So the name of this right here is actually, its full name is code.kind, because it's in there. Just like when we put static color green inside of color and it was color.green, that's what it is. Now, when we're inside code here, when we're doing our code inside here, we don't need to put code, okay? We can just say kind because type inference. Swift knows that we're inside code. But if I refer to kind anywhere outside, I'm going to have to say code.kind. So if I refer to it in CodeBreaker or in my UI, I would have to say code.kind. Now, because of type inference, I'm not actually going to have to do that. You'll see, because it can always be inferring it. But I would have to call it that if I wanted to. So that's an excellent question, namespacing. And when do we put things inside versus outside? Like I didn't put code inside CodeBreaker. You could imagine I could, and then it would be CodeBreaker.code. A lot depends on how significant the struct is. Something really minor like this kind that's intimately tied to the code, I'm probably going to put it inside. Something that kind of has a life of its own, like a code is eventually going to have, I'll have it outside. So it's an art of programming thing, but that's generally the guidelines I'm thinking about. So peg, what about peg? We need a type for peg. All right, let's try that. Struct peg, and it needs what? A color, obviously. Pegs need colors. What else is a peg? Anything else in a peg? And when I have a struct that just has one little thing in it like this, unless I have a lot of funcs I want to put on a peg, which I can't even think of any funcs, I'm actually not going to make peg a struct. I'm going to use a cool feature in Swift called type alias. I'm going to type alias peg to equal color. And that means that everywhere in my UI that I use the type peg, it's actually going to mean a color. So type, it's truly an alias, right? Peg is just an alias for color, because that's all a peg is to me, at least now. If I start having more needs for pegs to do more sophisticated things, I guess I can switch it to a struct later. But right now, I'm just going to set it equal to a color. Type alias is almost like documentation, because I could have easily just said a code is an array of colors. I could have said that. But by saying it's an array of peg, I'm kind of telling people reading my code, oh yeah, it's a color, but it's a peg. It's one of the pegs, right? It just helps me think about my design here. But I got a really bad error here. This is a nasty one, and this is when I'm going to do the bad thing I said I shouldn't do, which is that color is fundamentally a UI thing. Now, you might think of color as like, oh, green, that's just green. That's nothing to do with the UI. But do you know that when you see something that's green on your screen on an iPhone in light mode and the same exact green on dark mode, those are two different colors. Incredibly, because your mind sees things on a black background a little differently. So the color system, unbelievably, is actually adjusting that thing so that when you go back and forth between light mode and dark mode, your eye, your brain, sees the same green. It's just really amazing what they've done. However, it means that color is a very UI thing. So when I say this, I'm kind of breaking my rule of model is UI independent. Now you're going to fix this in your homework, because I'm going to make you make CodeBreaker a much more exciting game than just colored pegs. You're going to have pegs that are emoji faces or something like that. And in that case, you're going to switch this peg to being a string. And the string is going to have to encode a color by name, probably. So you have the string green, and then your UI is responsible for taking that string of green and turning it into foreground style color green. And one of the cool challenge modes, extra credit if you want to think of it, in the homework is go use AI to figure out how to write the code that converts from a string to a color and back. So just kind of fun. I don't know how many of you used AI to write code, probably most of you, but it's really cool. And so I'm going to guide you through that a little bit in the homework. But I'm stuck with it being color for simplicity here. So instead of Foundation, I'm going to have to import SwiftUI. But luckily, I don't have to import all of SwiftUI, just something called SwiftUI Core, which is kind of like the core structs and stuff of SwiftUI. Yeah.
Is it possible to import both SwiftUI and Foundation?
Yeah, so the question is, can I import SwiftUI and Foundation? And the answer is SwiftUI itself imports Foundation. So you're automatically getting it. You can say it again, but SwiftUI can't function without Foundation, because Foundation has things like arrays and dictionaries and ints, and I mean, you have to have SwiftUI can't live without it, so it imports it itself. So this is it. This is my entire model. None of the behavior of the game, but this kind of the storage, and it's kind of a good starting point for me. So now let's go back to our UI, and I'm actually going to put it on screen at the same time. I'm going to go over here to my content view, a little space over there like that, and it's putting my preview now down at the bottom, but I'm going to stop having my preview up there. Remember, I go up here to this button and say Show Editor Only. It takes my content view away. And I want to do what I was saying, where I want to make this code on the right, which is the view of my app, the UI, be a manifestation of what we see on the left. And the first thing I need to do is have one of them. My view needs to have a CodeBreaker struct, an instance of a CodeBreaker struct that it can show. So I'm going to do that just by adding a nice little let up here. Let the game, I'll call it, which is of type CodeBreaker, equal a CodeBreaker. I'm going to try and create a CodeBreaker there. And so now I have a little variable inside my view that I can use to show all the pegs and do all the things, and eventually it's going to do all the logic too. So this game is a very powerful little variable that I've put in there. But it's not working. What's it saying here? Missing arguments for parameters master code, guest, attempts, and peg choices in call. It wants me to start typing here, oh yeah, master code is this, and a guess is, it's making me put values for all of these variables. And why is it doing that? Why is it doing that? Yeah. Yeah, because those variables have no values. And in Swift, we can't have variables no values. So you can't create a code breaker with these things with no value. So I'm trying to create a code breaker over here in the UI. It's saying, fine, but give me those values because I can't create it otherwise. Well, we don't want that because clearly the UI using the code breaker, it doesn't want to have to create the master code itself and create a guess. And that's all stuff that the logic of the model should do. So let's start putting some defaults over here. Master code, it's a code, so I'm going to create a code, and it's going to have some arguments. And the guess is also a code, and that's going to have some arguments. Our attempts is an array of codes, right? Our peg choices, well, this is an interesting one. We'll let AI do its trick here and make red, green, blue, yellow be our choices for our pegs. All right, now this is not where we're going to go long term. We want to be much more powerful and flexible. And like I said, in your homework, not only can these be colors, they could be smiley face emoji or something like that. But here, we're just going to start here, and we'll work from there. But now, of course, this, yeah.
Is it a good idea if you know something should change to declare a let instead of a var?
Yeah, so that's a great question. It's like, how do I know to start off making this be a let versus making it be a var? And I think that there's an approach, which I believe in, which is always start with a let and only switch it to a var when you actually are going to change it. The compiler's kind of going to force you towards lets anyway, because it's going to give a warning every time you have something that you don't, modify that's a let. So let's just always start let, because otherwise they're the same. That's the only difference, is the editable or not. Yeah.
And on that note, in CodeBreaker struct, since peg choices, at least at this point in time, is a static set of 4 choices, should that just be a let as well, or does that matter?
Great question. So he's saying peg choices, I'm not going to be changing peg choices, so should this be a let? And absolutely it should be a let. Because we don't have any functionality that's going to let you change peg choices in the middle of a game. Should be kind of hard on the guesser. So yeah, that one should be a let. So I just made that a let. Very good question. So we've got this game right here, but we've just pushed off the arguments thing to this side, because this thing is saying the same thing, missing arguments for kind and pegs. Well, this is a little different here, though. When I'm creating a master code, I actually want to tell the code the kind, because this is a master, and then this one, kind, is a guess. And when I start adding attempts to this attempt array right here, they're going to be of kind.attempt. So I want that. But what about the pegs? I'm still not doing this missing argument thing. Is still saying you're not doing pegs. So what about this pegs? Well, interesting. Look, long term, I eventually want the master code to have random pegs, and I want the guess to probably have missing pegs until I pick the code I want. But in the meantime, let's just make this hardwired to something, and we'll fix that later. So I'll just say maybe green, red, yellow, so we can recognize it. This is going to be all codes get created with those 4 pegs for now. Eventually, I'll fix it to do the right thing for different kinds of codes. All right, good. Look, no errors. Excellent. So now I have a game right here in my content view. And actually, you know what? I'm going to change this right now. Content view is the wrong name there. Content view is a name we got from the generic template from Xcode when it didn't know what the heck we were doing. It means that this is the view of my content of my app. It has nothing to do with CodeBreaker. But what is this view really, this helicopter view? It's a CodeBreaker view. It's going to show a CodeBreaker on screen. It's going to be a visual manifestation of a CodeBreaker. So I'm going to rename this to CodeBreakerView. Now, this actually appears a lot of places. It's in this comment. It's right here. It's actually the name of the file. It's over in our main program right here. It's just lots of places in our preview. So I could go over here to my navigator and go to here and go search and replace, and I could type in content view and replace with CodeBreaker, but there's a lot better way to do this, which is actually refactor my entire project by saying right click. I select it and do right click and go down to refactor, and the very first refactor is rename. And now, as soon as you do that, it's going to go through your entire project and look where everything semantically called content view. It's going to select them all for renaming. Now, it didn't choose one of them, though. See, they're all in blue, except for one, which was the comment in the header of this file. It wasn't sure, is that really a content view, or is that just the word content view? It's in a comment. I'm not sure, you see. But I can click on it and add it to the list. I have to click on it again to take it off. And so all the things that are blue are going to get renamed here. And I'm still editable. See, the thing I clicked to edit, it's still editable. So CodeBreakerView. You see how all of them are changing? Yeah, it looks good. Now I'm going to click rename. And so it renamed everything. It renamed this. It renamed the preview over here in our files. It renamed the file to be CodeBreakerView in our main program. It renamed that. So it did absolutely everything we wanted to do there. We have this CodeBreaker view. It's a visual manifestation of this CodeBreaker, this instance. By the way, I would never type that way. I would say this. Type inference. Clearly, I don't need to specify the type of that game. It's clearly a CodeBreaker. I'm setting it equal to a CodeBreaker. Now that I have the game, I can start going through my UI and having it fill out with the game. So let's actually go back to having this be the main view here and also get our preview back so we can see what's going on. Here's our preview. Right now, our view only has these random things for testing. Instead, I want these to show my game. Specifically, I want this top row right here to be my master code. I want this to be my guess that I'm working on. And then I want down here a list of all my attempts, all the past attempts I've made. Let's just change that right now. Easily done. You see I got Peg's color here. This is hardwired to this. I'm going to make this be my game's master code, Peg's. And voila, I got green, red, red, yellow, which is what we made. Remember in our model, green, red, red, yellow was what all codes are. All codes are green, red, red, yellow. And I'm going to do the exact same thing here with my guess, guess.pegs. There it is. Oh, green, red, red, yellow. That's working perfectly. And I could do the same thing with my attempts. Game.attempts sub0.pegs. And of course that crashes my app because my attempts array in my model is empty. Right? It starts out empty. Everyone agree that back over here, when we created our attempts, look at that, it's empty. By the way, here also, we would do type inference and not type that because we obviously have this. Or we could do the opposite, where we put that type there. And here we just say open square bracket, close square bracket, which is an empty array. One side of the equals or the other has to have the type, but we can type inference the other side. So we get an empty array, so that's crashing, so we can't do that. But what are we going to use to do this? For each, of course. We're going to do a for each, but we'll do that in a minute. This is great, this is working, but there's something else inside pegs, which is the little black and white pegs. And for each code, at least the attempts, not for the master code because they're all black, right? They're all exact matches for the master code. And the guess, probably don't want to show that while this person's editing it. But the attempts certainly need their thing. So I'm going to change this func pegs to instead be func view for code and pass it a code instead, and then have it build some view for me. So I'm going to get rid of this pegs color thing, and then I'll change the color up here to say view for the master code, and also a view for the guess. And on my for each, I'm going to be saying view for attempts. And inside this view for code, since I'm given the code, I have to grab the pegs to get the colors, right? Here's the colors. It used to be pegs for the colors. So I'm going to say code.pegs. And then same thing down here. This is the colors, code.pegs. We've hopefully fixed everything here. Let's build, force it to recompile. No errors, no little red things up here. Start our preview back up again. Woohoo, it's working. Master code and guess. Now let me say something about this name, view for code. I'm not a fan here. I don't really love that name, view for code, although it's not terrible. Because the fact that this code is a very specific kind of type, it's clear to someone reading the code that I'm making a view to show you a code. But what really should I be doing here? Anyone want to suggest something would be better than view for code? How about helicopter view, code view, where it takes a code as its argument? That would be way better, but I'm not going to take time to do that. We'll do that next week when we have a little more time, because we've got a lot to cover today. So we've got that. Things are working great. Now let's make our guess work. Because right now, how do I guess? It's like, I want to tap on these and somehow change them so I can guess what I think the code is. Now we're talking about multi-touch inputs. Swipes and taps and things like that. We call that multi-touch input. So I need to get some input from the user so that when I tap on one of these pegs, it changes the color. There's a couple of ways to do this. We're going to do it in kind of not so great way today, which is that every time I tap on it, it's going to cycle through all the peg choices. And whatever the colors it can be, it'll just cycle through. Tap, tap, tap. It can go green, yellow, red, blue, green, yellow, red, blue, green, yellow, red, blue, until I get to the one I want. Not a great user interface to do that. It's a lot of tapping just to get the guess the way you want. On Monday, what we're going to do is we're going to have like a keyboard, a thing at the bottom that lets it just go blue, red, red, green, right? Much better. Today, we're going to do this tap because we're just learning about multi-touch. We're just learning how to put it together here. So how do we do that where when I tap on a view, it does something? I'm going to put myself in select mode and say, what draws this? Oh, there it is. You see it selected on the right. Okay, so when I click on this, I can see this is the rounded rectangle that draws that. Okay, great. I want to make it so when I tap on that view, it does something, basically cycles through the peg choices. So to do that, I use a view modifier, .onTapGesture. And that means when a tap gesture happens on you, Mr. View, execute this inline code, right? Everyone understand that syntax there of having the inline code, the closure there? So we can do whatever we want in here. Now, cycling through the peg choices, that's a model thing. That's not a UI thing. The UI did its job. It got the tap. But now it's time for the model to do its job. It knows what the peg choices are. It would know how to cycle through. So I'm going to ask the game to please change the guess peg at index. Now, as I typed that and I realized, change guess peg, I really only want to call this if you tap on a guess peg. So inside here, this is just normal code, completely normal code like you're used to. So I can say, well, if the code's kind equals .guess, then please, Mr. Game, change the guess peg. And it's up to the model to decide how it changes the guess peg. I'm just telling it to change it, so it's going to change it. And like I said, I decided I'm going to cycle through them, because that's a good way to do it. It says here, value of type CodeBreaker has no member change guess peg. Of course, that's absolutely true. It does not. Well, let's go and add it. We've got our CodeBreaker here. I'm just going to add a func called change guess peg at, and I don't want to use the variable at inside here. I'm going to say at index and put the int there. Oops. And inside here, I just want to change the guess peg that's at that index to the next thing in the cycle. This is actually an important little function that I'm going to go through here because we're going to see optionals at work for the first time. We're going to need an optional to make this work. But here's my logic for doing this. First of all, I'm going to get the existing peg that's there by saying let the existing peg equal the guesses pegs at that index. Because obviously I'm trying to change the guess peg at that index. So I just got what's there now. So I don't know. I clicked on it. Maybe it's a blue peg right now. So I just got blue. Existing peg right here. I didn't do its type, but if I alt-click on it, it's of type peg. Notice that alt-click showed me the type alias type right there, which is kind of cool. Peg as a type alias. So I've got the existing peg. Now I'm going to use a very long variable name to make it clear. I basically want to say let the index of existing peg in the peg choices array equal something. That's kind of what I want to calculate here. And actually, let's let AI do its thing here. It seems like it's got a good idea for doing that. And here's what it said. Go look into the peg choices and find that existing peg. And the reason I want to find it is because I want to then go to the next one. Right? I'm just looping around, going around the peg choice. I want to go to the next one. Now, when you click on first index of, look what it returns. Self.index, which for array, that's an int. Int is how you index into an array. Self.index question mark. That's that syntactic sugar that says this is an optional. And why is this an optional? Because if I look for the first index of something and it ain't in there, I'm going to get none. Exactly what we talked about in the slides. So that's great, but the AI said, oh, and if that's true, I'm just going to crash my program. Totally unnecessary here. We don't need to be crashing our program. Instead, I'm going to check and see if it's in there safely, and I'm going to do that with this if let. So I've already got let. I'm just going to say if I can let that happen, then I'm going to have some code that I will execute with that being known to be not none. In other words, I'll never get to the inside of this curly brace if this thing returned the none case of that enum, because I'm saying if I can let it equal that. It reads kind of natural, kind of English languagey. So now that I've got the index, I'm going to let the new peg that I want to put in there, which is going to be rotating around. Oh, and look, AI did it again. AI's got it right there. I'm going to take the index of the existing peg and add 1 to it, but I'm going to have to modulo. Everyone know what mod is? That's basically integer remainder, because if I plus 1 off the end, I need to wrap around back to the 0. So it's calculating the index there, but I'm just going to go straight to the thing and say, give me the peg choices at that index. Don't need to make it. It tried to make a little let just to be the index, and then it was going to do another line of code that looked in the peg choices. But I'm just going to look directly in my peg choices there and get the +1 wrapped around with mod. Everyone believe me that that's going to rotate through and get me the next color from the peg choices? All right, now I'm going to just say guess.pegs at that index equals the new peg. But what if, for some reason, the peg that's already in the guess is not in my peg choices, which actually is going to be true, because I'm going to change my guess to start out with none of the pegs set. They're all going to be missing pegs, basically, until you start clicking on it. So when the first time you click, it's not even going to be in there. So what are we going to do in this else case? Really easy. I'm going to say guess.pegs at that index. In that case, equals the peg choices.first. First is just a var, an array that says, give me the first thing in your array. But that, too, returns an optional. Because if the array is empty, it returns the none case. Because how can it give me the first thing in the array if the array is empty? Right? So again, you can see that the AI is trying to crash my program for me here, which, again, I don't want to do. If you play CodeBreaker and you have no peg choices, not going to be much of a game. But I probably don't want to crash my program, although maybe I would. Because maybe I'm in development of this app, and that should never happen. All my other code is supposed to never have that happen. And if it does, I want to find out, because I want this to crash in the debugger right here. So I can see, oh my gosh, peg choices is empty. So exclamation point is not always bad, but it's a little more of a development thing maybe than a shipping code thing. But we're going to do a different thing here, which is if it's not in there, then I'm going to use the nil-coalescing operator, otherwise known as the optional defaulting operator, to pick a default thing. So what should be my default? The AI wants it to be green. Maybe that's the AI's favorite color, okay? But I'm not going to do green. I'm going to do a special thing here, code.missing. Now I'm going to add a new static var. Here it is. It's going to be a static let, actually, called missing, which is of type peg. And I'm going to make it be clear. Clear is a great color for a missing peg, because it's clear. It'll be not showing up in the UI. So that's kind of fun to do it that way, to make it be clear. But notice that I'm referring to it as code.missing. That's because this is a static let. So it is namespaced. It's basically a global variable called missing, but it's namespaced because I put it inside code here. So it's called code.missing. And no, I can't just go like this, because you can't infer that for sure that's the missing you're talking about, because we're talking about pegs here, not codes, pegs. So there's no type of code for it to infer here. So code.missing is what we need here. Now, if I had an array of codes or something like that, then maybe we'd be in business, but we can't always get type inference every time we want it. Everyone cool with this static let? So it's still complaining. It says, cannot assign through subscript. Self is immutable. All right, I told you one of the great things about structs is that they're immutable by default. They can't be changed, which is great because you're passing them around and you're making copies of them and you're never having to worry about somebody damaging your struct. But as we said, if you had an array of 10,000 things and you pass it as a copy, it's not going to make a copy of all those bits. It copies it efficiently, and it waits until you put it in a var and try to modify it, and then it copy on writes. Then it makes an actual copy and changes it. So what Swift is telling me here is, you got to tell me when I got to do copy on write. And what we're going to tell it is, this function, change guess peg at, it forces a copy on write, because it does. It changes my guess pegs here. So the way we do that is, in func here, we say mutating func. You have to do copy on write if someone calls this function on a var version of this struct. This is something that takes some getting used to, that you have to mark any function that actually modifies something like that to be mutating. But this is actually going to cause a problem back over here, because now this thing is saying, oh, you cannot use a mutating member. Member, by the way, means member function on that struct. Okay, that's probably terminology you're used to from object-oriented programming as well, right? A member function is an instance function on that struct. It's saying you can't use a mutating member on an immutable value. Game is a let constant, it says. Game is a let constant. And it actually is offering to fix it by making this let be a var. All right, you see where it's saying fix? So let's try it. Watch this. Fix. Ooh, it made it a var. Okay, problem solved, right? Well, not. And now it's got a different error. It says, cannot use mutating member on immutable value. Self is immutable. Because this is a struct as well. So if I want to mutate it, I have to say that this is a mutating func. Now you see what you just saw me do right there? Don't you ever do that, okay? We never have mutating funcs in views. And why is that? Because I told you all the views are in a big let somewhere. So it's never going to work to do mutating. And actually, you can see it right away why it happens. Look what happened when I made that a mutating func. I'm trying to call it from my var body, and that's saying you can't use a member here because self is immutable. That's because this var body is what? A read-only var. So it can't be mutating something. It's read-only. So we're stuck. We can't not have it be read-only. Var body is by definition computed. It's read-only. So that's why we can never have mutating funcs. And that's why SwiftUI made the choice to have all the views just be read-only. And it works great. Now, how we can solve this problem, though, because I have to change that. I'm trying to change that guess. I need to make that thing happen. Well, this is where you're going to put @state here. @state's a little macro. It's actually going to make a little var in your view, which is a struct called state. And inside that state struct is a class pointer. Remember, classes are the thing where we have reference things and stored in the heap. So there's essentially a class pointer inside this little state struct. Now you're like, where is that state struct? It's there. You can't see it. It's actually called underbar game. And there is a couple of times when you actually reference it, and I'll show you that in a few weeks. But most of the time you don't. And this macro makes it so that when I say game, it indirects through that thing in the state thing out to the heap. So it's storing game out in the heap for us. But the good thing about @state is it's doing it in a way where, A, we have to mark it in this way. So if we search through our UI for @state, we can find all the sources of truth. Because these are the only things that are mutable. Nothing can be mutable in a view without @state. That's the only way to make it mutable. That's the only way to make mutable state. So it's great. It's marked. It's also only making this one var mutable. I might have other vars that are lets in there. They're not making them all mutable. It's just making this one little thing here. So it's really contained, helps contain the world of mutability inside your view. And notice this. Look, it compiles, and I can even run my preview, and it's working. Can I click? Woohoo! I'm tapping. It's changing them. Woo! I can cycle through all of them. How about if I click on the master code? Oh, it's not doing that because I say if kind equals guess right here, so it's not doing that. Excellent. It's working like a charm. So I can actually guess. And that guessing is happening because every time I tap on this rounded rectangle, it is, if it's a guess peg, calling the model and asking the model to do something. Change the peg. Yeah, so the question is, why are we saying it's onTapGesture versus onClick? It's only a click because I'm doing this in the simulator on my Mac. Normally, I have my phone in my hands, and I can't click. I can only tap. It can be confusing, especially with the keyboard and with tapping. You think of it as clicking, but this is not a Mac app. This is a simulated iOS app, so that's why we're saying tap. Now that we've got this going here, let's add our attempts. We've got master code. We've got a guess that lets us guess. We're making great progress. Let's do our attempts up here, which we said needed to be a 4 each. And what is it before reaching over? Our attempts. Can we do just the attempts? Unfortunately not, because attempts could be the same. And some people who aren't very good at CodeBreaker, they guess something, and then a few times later they guess the same thing, and they're like, oh no, I already guessed that. So we got to leave that in there. So the attempts aren't unique, so we can't do ID self. So we'll do the same thing, indices, because the indices of the attempts are clearly unique. ID \self, the indices themselves are integers that are unique, and index in, just like we always done. And what is this in here? Well, it's just view for the game.attempts at that index. Voila, we have our attempts. That's all there is to do it. Now, one thing hopefully you're seeing here is that once you have the right primitives, then it's like there's almost no code in SwiftUI. Look, this is our entire thing here. It's only 4 lines of code to get this working, but it's all based on having this primitive, which is like a code view. View for code. Could be a helicopter view, code view probably should be. But if you have the right primitives, then the rest of your UI gets really simple. And someone looking at this can very clearly see what this UI is. It's a vertical stack of these views, these code views. We got to see if our attempts are working. How do we do that? We got to be able to guess. Right, so we need a guess button. So let's add a guess button. How do we do a button in SwiftUI? Well, of course, we use a button view, right? Now, there's a lot of ways to create a button. A button actually can have on it any view. It can have a VStack, it could have an image, it could have text, anything you want. But of course, it's very common for a button just to have a word on it. So we're going to use the version of buttons initializer that just takes a word and an action closure to do. And here we want the word guess. And then inside our action closure, again, now we're back to, we've done our job as the UI, we collected that guess. Now it's time for the model to do its job, which is play the game. Because all the game playing lives in our model. So we're going to say game dot, how about attempt guess, please, Mr. Game. And it's up to the game to do that. Now, what's really interesting here is when I did that change guess peg and I was clicking on there, notice I didn't have to do anything that said, okay, and now update the UI. As soon as I changed that change guess peg thing, it just updated the UI. And that's the way SwiftUI works. The whole thing is based on this reactive nature. This is why we call it reactive. It reacts to changes in the model automatically and just redraws only the things that have actually changed. In that case, it would redraw only that one view. When I click here and change that peg, it only draws that one view. Well, same thing here. When I attempt a guess, it's going to add an attempt and probably reset the guess thing eventually and all that stuff. That's just going to automatically appear in our UI because our UI properly draws the attempts, hopefully. We'll find out here. So let's go back to our model and teach it to do this. This is a really fundamental part of our model here, is to attempt a guess. So we'll go back here. Let's clean that up and say, let's put it up higher. Actually, it's so important. It's func attempt guess. And what do we need to do? This is incredible. I'm just going to say attempts.append that guess. Now, is that really going to work? No, it's so close to working. But here's the problem. Guess, right here, it's a code. What kind is it? It's a .guess, right? Its kind down here is .guess. And the attempts really want to have kind.attempt. So we need to take our guess, make it be kind.attempt, and then put it in our attempts. So now we're going to learn about the greatness of value types versus reference type. Because to create a new attempt here that is just a copy of the guess but has a kind attempt, I'm going to say var attempt equals the guess. That copies the guess. That makes a copy of it. All right? And then I'm going to say attempt.kind equals .attempt. That is modifying only the copy. Guess is unaffected. Guess is still of kind guess. It hasn't been affected by this line of code at all because attempt is a editable, mutable copy of it. And then I'm going to append that attempt. So now I've appended a copy of the guess that's been changed to the kind attempt. Everybody cool with this? So this is different than you're used to because normally if you did this code with a reference type, it would have changed the guess to be an attempt, and that would be bad. But here, value types does not happen. Because that line of code here copies that guess, literally makes a copy and puts it in there. Yeah.
And you said that on the back end, like the garbage collecting is happening for now that you're not going to need the guess anymore. You don't need to like deallocate.
Yeah, let's talk about that. So he's asking a question about, oh, garbage collection is happening somewhere, but actually there's no garbage collection anywhere in Swift. And what it does instead is something called automatic reference counting, where it actually counts the references, and when it gets to 0, then it frees it up. But that only happens with classes. That doesn't happen with structs. Structs don't need to be garbage collected because they're right here in place. So when they go out of scope, they're gone, right? And if they're in a struct, they hang around until that struct goes out of scope because the value is in there. It's not pointed off somewhere else that has to be cleaned up. It's right in there. That's another advantage of value types, by the way. No garbage collection or any of that, marking and sweeping and none of that. Good question. But we got a problem here. Cannot use mutating member. It's immutable, of course. Same exact problem. Attempt guessed is clearly going to mutate our thing. So mutating func. Attempt guess. Back to our view over here. Everything seems to be compiling. Oh, our preview came up. I can make some changes here. Let's make it all yellow. Here's an all yellow attempt. Ready? Guess. Oh, it did it. And how about an all green attempt? Like this. All right, ready? Guess. Whoa, it's doing it. It's putting the for each in there. However, this is kind of a not so great UI. I don't like a couple of things about it. One is I don't like that every time I make a guess here, the guess button jumps out up from under my finger. Okay, remember I'm tapping here on my phone. I tap on there and it jumps out from under my finger, moves down, and actually the thing I just guessed jumps under my finger. That's very disconcerting. We do not want that kind of behavior in our UI. Also, I don't think it's quite right that it's putting the thing I just guessed down at the bottom. I think I want that to be right next to the guess, because now I'm going to make another guess that's probably slightly different than the last guess I made. I don't want to be looking up and down and up and down. I want it to be right there, my guess and my last attempt to be right next to each other. And then there's another thing I'm worried about. What if I make 10 guesses? It's going to start pushing off the screen. Because this VStack, it's stacking these codes on top of each other, and it's staying in the middle of the screen. And so it's growing every time I add one. And eventually it's going to grow off the top and bottom of the screen. I'm not going to be able to see my master code. I'm not going to be able to see my last attempt either. So that's bad. I can fix all those problems with 2 lines of code. Actually, with almost 2 words of codes. The first thing I'm going to fix is making it so that my most recent attempt is up near my guess. And I'm going to do that by taking all my attempts and reversing them. I'm going to make the most recent one be first. And I can do that right here by taking my indices and reversing them. So reversed is a function. It's just a simple function on collections. Indices happens to be a collection. It's a range. I haven't really talked about range, but you can think of it as an array if you want, but it's a range. And reverse just flips it around to opposite direction. It works on arrays, works on ranges, everything just flips them around. So now when I go over here and guess, do blue again, mostly blue, and guess, it stays there. And then if I pick a different ones here, watch this next one, right next to it, you see? So now I'm saying, oh yeah, I want to change that one. I'm able to kind of see it right next to me. So that's simple. And what about too many things going off the screen and the guess button jumping out from under me? Well, I'm going to fix that by putting this whole thing in a scroll view. I want it to scroll up and down, and that's going to fix both those problems. I'm going to put the guess and all the attempts in a scroll view. A scroll view is just a view. It is a kind of an instruction manual view, kind of like VStack. And you put the things in there, and look what happens over here. Couple of things. One, a scroll view fills the entire space available to it and then puts the things inside in a scrollable view. See that? I can scroll on it. Oops, I guessed. That's what a scroll view does. So since scroll view fills all the space, it pushed that guess button down to the bottom. So it was kind of a nice little side effect to have this guess button down here. So now if I click a guess here and hit guess, it does it. Now, this is almost exactly what I want here, because I can scroll by. And since my most recent guess is near guess, I don't have to worry about the old one scrolling down off the bottom, and I have to actually scroll down to see them, because I probably don't want to see them. They're so old. But this is a little abrupt. When I click guess, like I put some things in here, I don't know, add colors, and I hit guess, watch what happens. It kind of just jumps. And if you watch any good iOS UI, it doesn't jump. It's got animation. Things are smooth. They scroll. They fade in and out. That kind of stuff. We want that too, right? Now, I'm going to spend a whole week talking about animation. It's so important to building a good UI, week after next. But here I'm going to show you just a little bit of how it works by showing you with animation. Okay? So if you put with animation around anything, it will animate that change. Now, it has some default choices of how it does animation. Opacity is a big part of how it does animation. But in a scroll view, animation means move things out of the way if you want to make room for something new. So watch what happens here. Let's do a guess. This first guess is just going to fade in here, right? But look at the second guess. Look what happens to this first guess when I do a second one. Whoop. See, it slid down, and the new one faded in. Now, I don't love this animation because that fade-in animation is kind of overlapping the scroll-down one, and I've got some really good ideas for how to do this animation that really look cool and will make users go, ooh, that's cool, which is what you want. You want your app to be cool. But we're going to talk all about that in 2 weeks. This is just a brief preview of doing animation there. What about the white and black pegs? Those things need to be showing for each of our attempts what's going on. So how are we going to do that? Now, I am going to be time constrained here, so I'm going to add a function to code here that calculates those pegs, but I'm not going to go through the code until Monday. And the reason why I'm doing that is I need to get this done so you can do your assignment too. And then you don't need to know what's going on in here to do assignment 2. And then I can go back and tell you on Monday what's going on in there. And it actually has some very interesting things, especially related to closures, this thing, closures. So anyway, here's the function I wrote. And there's many ways to do this thing. So I don't want to make it sound like this is the only way to do it. But what this does is it matches against another code. That's why it's called match against other code. And it returns an array of matches that line up with the various pegs. So if the first peg is a perfect match, it'll have .exact in the array that it returns. The second one is in there, but it's not at that position. It'll have inexact. If the next color is not even in the master code, then it'll say no match, right? The same matches we had before over here in match markers. It's going to return an array of these things. It's basically something suitable to give right here. Exactly the same thing this wants. Now remember that our match markers doesn't pay attention to the order. It's just how many exacts, how many inexacts. So that's good. We don't want it to because we don't want to give the user too much hint. But the thing I wrote over here in the model, it does actually return you the positions of the exact and not matches. So we're going to look at that later. But we've got this match against, and we can use this match against over here in our view where we are putting the matches. You see, here's match markers, and right now we're just using exact, inexact, no match, exact. But I could say code.match against the game's master code. All right? So match is that function I just added to code. It matches against another code. I'm matching this code against the master code, and it is working perfectly. You look over in our preview, the master code, its pegs are all black because it matches the master code perfectly. All pegs are right, and so is our guess. But if I start changing my guess, oh no, ooh, it's changing them, okay, as I click through them. Now, clearly we don't want either of these two things to be happening. It's useless to put the 4 black pegs for the master code. Of course it matches. That's meaningless information. And I definitely don't think we want to be changing those things as people click. That's going to make the game way too easy, all right? Just kind of keep clicking until you get all 4 black, basically. So we're kind of on the way. But what's really going on here is that the only time that having those matches makes any sense is with an attempt, not with a master code or a guess code. So what do we do when we have 3 different discrete things like that, but only one of them makes any sense to have some data associated with it? Huh? And yeah, I hear something to say. Yes, we're going to do an enum, our little enum over here, this thing, kind enum. We're going to add associated data just for the attempt case. So I'm just going to say match here. And again, for this association data, I could put a little label like the matches that went with this attempt, but really that's unnecessary. If I have an attempt kind and it has an array of matches, that's clearly the matches for that attempt. I don't need that extra word. And I could put it in there, but totally unnecessary. You see how associated data works? I have these 3 different kinds of codes. Only one of them needs this data, so I'm putting that data in the kind enum there associated with that kind attempt. And if I want to make things kind of nice for calling, I could create a var matches in code, which returns an array of matches, and switch on my kind. So I'm switching on my kind and saying, if your attempt, then go grab that association data and return it. But any other one, just return empty array. So you see how I'm using switch right there to look into my kind. I'm switching on my kind. And if it's an attempt, I'm getting the matches and returning them. This is just kind of like a convenience read-only var we have right here. Otherwise, I'm returning nothing. Now that we have this associated data with attempt, we need to set it. It's actually going to force us to do that right here. You see this says member attempt expects the argument of type match. Because I'm trying to set the kind to .attempt, you cannot set .attempt as the kind unless you give the match. Luckily, the match is easy. It's the guess matched against my master code. Right? So when I create attempt, I have to say that. Now, this also broke another thing, which is kind of interesting. Back here in my view, probably hasn't compiled over here. Oh, okay, it's a good example of this. Okay, so I just hit compile, and nothing is happening. What's happening here is that the compiler is struggling with a view builder. And I told you this would happen, and now you're seeing it in action. You see at the top, it says building 8 out of 12. All right, well, number 8 out of 12 is probably this view builder, or is this file, and it's trying to build this view builder right here, and it is struggling. It cannot do it. Now, I think it's eventually going to figure this out, so we'll wait it out for a second here. But I don't want to waste all of our time here waiting for this thing to do it. Ah, it did it. So it took a really long time to do that, but it did figure it out. It says referencing operator function equals on an equatable requires that code.kind conform to equatable. That's actually a very good error message there. So let's talk about equals equals. What is that in Swift? In all other languages, or most of the ones you know, equals equals like a built-in operator. Okay, it only works on ints and floats and strings, that kind of thing. Swift, no, equals equal is just a static function on every struct that can do it. Simple. It's called equals equals. Literally, static func equals equals takes two arguments, the left-hand side and the right-hand side, and it returns a bool, whether it's true. Now, why don't we see equals equals? We were doing equals equals here, and we didn't have to do that. Well, that's because if you have an enum that has no associated data, you automatically get equals equals. It exists. It's just the compiler is doing it for you behind the scenes, right? Some other code somewhere is doing it. But once you add associated data to an equals equals, the compiler stops doing that because it's not sure whether an attempt that has the same matches really is equal, because it just doesn't know enough about what the associated data is. But you can ask the compiler to keep doing it by going to your kind, enum right here, and saying, please behave like an equatable. Remember we have behave like a view? This is behave like equatable. Behave like equatable means you have that static func equals equal. That's all it means. And normally you would have to provide that equals equals yourself. Just like if you behave like a view, you have to do var body. If you want to say you behave like equatable, you have to provide static func equals equals and go calculate it. However, in this case where your associated data, all of it, is itself equatable, then it can generate it for you. It can synthesize. It's called synthesize the equals equals for you. So you don't have to type it in there, right? Because otherwise I would have to go here and say static func equals equals with a left-hand side that is a kind and a right-hand side which is a kind and returns a bool. And I probably would switch on the left-hand side and see what it is and compare it to the right-hand side. I could do that. This is what the function is, and you can type that. But it will synthesize that for me as long as this, all of the associated data, is equatable. Now, is this equatable? And the answer, it is, because array is equatable, and this is an array, if the things in the array are equatable. And a match, if you go look at match, it's the kind of enum that doesn't have associated data, so it's equatable. So you see how the equatable behavior is kind of rippling through here, and it's rippling all the way up to kind, because we're saying kind is equatable, and Swift's saying, okay, you've told me that it behaves like an equatable, and since all of your associated data is equatable, then I'm good to go. But it does mean if I wanted to see if two kinds that were attempts were equal, they'd have to have the same matches, which they would in our game. So that's what's going on there, and that's going to fix this over here. Fixed it. And yeah, so that was a great opportunity to show you the long build as it was trying to figure out this line of code was wrong because we didn't have that equatable, and it just took a long time to figure it out. Okay, but it did eventually, so give it credit. So we have got our kind with the matches in there, so we don't need to do this anymore, right? When we're showing the match markers, we can just ask the code for its matches. This matches is that nice little var I made over here that switches on my kind and extracts the matches if it's an attempt. Make sense? So this means it's only going to show those pegs when it's an attempt. If it's a master code or a guess code, it's going to be empty. This is default returns empty, so we're not going to see any anymore. Let's see if that works. Go over here, rebuilding our preview. Hopefully we won't see any pegs, and we don't. No pegs next to the master code or the guessed. And if I'm clicking on things, it's not drawing the things here. Okay, what about our attempts? Well, they do have it. Yeah, let's change something so it has a match. Yeah, look at that. It's actually working. I mostly did it this way because I just wanted to show you how associated data works, and that is how it works. All right, what else do I do? You know, I freed up some space up here. I'd like to put my guess button up in here. Because I'm working up here on my guess, go down. Oh, I have to move my finger all the way down here and guess, all the way back up there. I'd like to be able to go click, 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 guess, click, click, guess. It would be cool to put my guess button right here. So we'll do that. It's really easy. First of all, I'm going to take my guess button out of here. Let's make a little var for it. Var guess button. Some view. There's a nice guess button right there. And how am I going to put it up here? Well, what is here? Here is where the match markers go for guess. So that's this, match markers. On top of this, I'm going to overlay the guess button. And overlay is a little different than Z-stack, right? Remember we had V-stack and H-stack, and Z-stack was things on top of each other. Overlay is lay it on top of each other, but make it fit in the thing you're overlaying it over, which is perfect here. I want that guess button to fit in the little space where the match markers go. So I'm going to say overlay and provide it a view, and I'm going to put the guess button there. But I only want to do that if it's the guess. Look, I don't want to be able to have the guess button on the master code. I only want it on the guess code. So I'm going to say if the code's kind is guess, not master, guess, then I have the guess button here. Voila. Now, the only thing that guess button is kind of small. There's room for that guess button to be a little bit bigger. So I'm going to show you how you can make something that has text kind of grow to fit a space. I'm going to do it up here on button. First, I'm going to set the font of this button to be the system font, where the size is really big, 80-point font. In fact, this system size is so big it can't fit. Look, I'm getting dot, dot, dot. But then I'm going to use another view modifier here, dot minimum scale factor, and I'm going to make it be 10%. And what that says is, I want this font to be 80, but minimum scale factor says, but I'll take as small as 10% of that, which would be 8-point font. So these two combinations, font system size big and minimum scale factor some percent, make it so that a text will fit. Also notice that I've put these view modifiers on a button, not on a text. But of course, inside the button's var body, it probably has a text in there. And we know the view modifiers that aren't used by outer views get passed down in. And that's true for button, too, just like it is for VStack. All right, we're almost there. The last thing we need is to make this code random and to make these start out as blank. So we want these things to be blank. We certainly don't want them to start out with the master code. That makes it easy to guess, I win. One click and I win. So that's no good. So how are we going to do that? Let's go back to our model here. And right now we have both of them. All codes actually get set with this right here. But I'm going to change this to use a constructor initialized on an array called repeating. So you can create an array that repeats something, and I'm going to do exactly what the AI says here. Repeats code.missing 4 times. So now my all codes start out with the codes missing. And if we go over here, they're gone. They're missing. They're clear. Remember, code.missing is clear. But there's a big problem here. Look, I can't click. Click, click, click. I can't even pick a one. You know why that's happening? Because clear, transparent, means all multi-touch events pass through. So it's not getting that multi-touch event because it's clear. It has to be at least a little bit opaque, even just 5% or 1% opaque, for it to get a multi-touch event. But there's a fix for that. There's a really great view modifier for that. So here's my rounded rectangle. It's called content shape. And content shape says no matter how much opacity or not there is in here, treat this view as if it's this shape for multi-touch. And so I've made it be rectangle. I could make it be rounded rectangle there, or if I were using circles for pegs, I could make it be circle. But I do content shape. Rectangle is fine. And now watch. When I click in here, ooh, it's getting the multi-touch events and letting me go through and guess. All right? Now, what about making this thing up here be random? Well, I'm going to go back to my code breaker. Inside code, I'm going to add something that randomizes the pegs. I'm going to call it func randomize from some peg choices. Give it some pegs. And in here, I'm going to do the first for loop. I'm going to do an actual for loop, not for each. For loops in Swift are only over collections. You can only for over an array or a range or something like that. So it looks like this: for index in my peg choices dot indices. I'm going through each index right there. And this thing is trying to do something silly. We're going to instead say pegs at that index equals my peg choices dot random. And if there's nothing in the array, then I'll leave it code dot missing. So random element is a really cool little function array that just grabs a random element out of the array. And that's the peg choices there in this case. And of course, this is a mutating func. This is mutating the code by randomizing all of its pegs. And so I need to call this randomize, though, up here in CodeBreaker. I've got to randomize this. How am I going to do this? Where do I call that randomize? Well, I really want to do it when I first create my game. When I first create the CodeBreaker game, I want to pick a random code. I never have to pick it again, just at the beginning of the game. And so anything you want to do at the beginning, you want to use an init. That's what an init is good for. So I'm going to create an init here for CodeBreaker, and it's going to say master code randomize from my peg choices. And that is going to do exactly what I want, it turns out. Now, I'm going to put another thing here. I'm going to use a print statement. And I can't believe I got this far before showing you a print statement. But I'm going to print out my master code. This is so I can cheat the rest of the quarter. That way I can see it at all times, even once we start covering the master code, which we're going to do on Monday, start covering it. And there's one other thing I want to do in my init, which is I don't want my peg choices to be fixed to be these four colors. I actually want to let the person who's creating my code breaker choose the peg choices. So I'm making peg choices be an argument to my init. And then over here, when I'm creating my code breaker, right here, I'm going to say I want my peg choices to be, and I'm going to choose earth tones: brown, yellow, orange, maybe black. Okay, it's my earth tones code breaker. And I might want to make it so there's a default, though. So I might say equals the old red, green, yellow, blue, just in case someone doesn't want to tell me the peg choices. They just want some default. I can do that. But in any case, the problem here is that it's saying returning from your initializer without initializing all of your variables. Inits always have to initialize every variable. No variables in Swift can't be initialized. Not allowed. So we need to initialize peg choices because it doesn't have an equals anymore. I took it off and put it here as a default for this argument. So I really want to say like peg choices equals peg choices. Can I do that? No, that makes no sense to say a variable equals itself. But I got a problem here because this is called peg choices and this is also called peg choices. And right now, it looks like it's saying that they're both this peg choices because we know the arguments to functions are lets, and it's saying you can't assign it, it's a let. So how do I distinguish when I want to do this? Well, the answer is we're going to say self.pegChoices here. Self.pegChoices means the peg choices in myself. And this is very common to do this, say self.something equals something, because we often want to have the argument to an init be the same name as our peg choices. Also notice that I can still have this be a let, because your initializer is allowed to give the initial value of a let. All right, let's see if this fixed everything. Let's go here. Go. Oh, it looks like a random code of earth tones. Let's do some different ones. I'm just pressing play down here. Yeah, it's picking nice random earth tones. That looks good. And let's go ahead and make a guess here. Yeah, that's a good guess. No. Let's try some there. Orange. Yeah, we got one right. Oh, we got 3 of them right there. Yeah, that one and that one. So this is working beautifully. The only other thing I was going to do is when this starts out and these are blank, right? These little things, I wanted to overlay a rectangle around the edge of it just so I could, as a user, see that there's something to click on there, because otherwise it's just an open space. And I was just going to do that. Actually, let's just do it. Overlay on top of that rectangle, and if the code pegs at that index equals code.missing, then we're going to overlay a rounded rectangle. Corner radius 10. We'll stroke its border with gray. There we go. So the fact that I'm overlaying on top, it makes the rounded rect fit the thing it's being overlaid on, and so I get this perfect rounded rect right there. All right. I mean, I think we got certainly far enough for you to do your homework. Your homework, by the way, is to continue to support colors, but you're also going to support emojis. So that over across the top here, it would be smiley face, frowny face, laughing face, or something like that. And those are just the pegs that are being used. And your game has to support both at the same time, which is why you're going to switch your type of peg to be type aliased to string. And then you're going to have to figure out how to turn those into colors. Okay?